In Chapter 4.6, we're going to start looking at square roots of non-perfect squares, something like the square root of 30. So what number can you multiply by itself and get 30? Well, you might be thinking, you can't, but you can. And we'll talk about that in a few minutes. But before we do, I would like you to please complete the table of squares, because we're going to use those numbers in a little bit. All right, we're going to start off with estimating square roots of non-perfect squares. So we're looking for the square root of 10. Well, 10 is in between the perfect squares 9 and 16. So the square root of 10 is in between the square root of 9 and the square root of 16. That's why you want to have that table handy. We're going to be looking for those perfect squares. Okay, now the square root of 9 is 3, and the square root of 16 is 4. So the square root of 10 is somewhere between 3 and 4. It's 3 point something. And I want you to estimate 3 point what? Estimate to the nearest tenth what you think the square root of 10 would be. Okay, continuing on, if we're looking for the square root of 20, 20 is in between the perfect squares of 16 and 25. So the square root of 20 is in between the square root of 16 and the square root of 25. It's somewhere between 4 and 5. It's 4 point something. All right, I'm going to do one more with you, and then you're going to finish it on your own. The square root of 200, the number 200 is in between the perfect squares 196 and 225. So we're looking for a number between the square root of 196 and the square root of 225, which means we're looking for a number between 14 and 15, 14 point something. Okay, go ahead and finish out the table, and then we'll talk some more. Okay, these next few examples are just to give you an organized way to show your work when you're doing these types of problems. All right, we're looking for the square root of 39. We just want to estimate it. So we're thinking in our head. You don't have to actually show this step when you're showing your work, but you're going to think in your head that the square root, or that the number 39 is between what two perfect squares? Well, 39 is between 36 and 49. It's going to be super, super helpful to you now and in the future as well to memorize those perfect squares, to recognize them really quickly, know them when you see them. Okay, so we're looking at the perfect squares 36 and 49. So we know that the square root of 39 is somewhere between the square root of 36 and the square root of 49. That means the square root of 39 is somewhere between 6 and 7. Okay, this is how we are organizing our work, organizing our thoughts for these types of problems. All right, let's do the next one together. Okay, so we are looking at the square root of 130. So we're thinking to ourselves, thinking, 130 is between which two perfect squares? Well, 130 is between 121 and 144. So that means the square root of 121 and the square root of 144 are going to be on either side of the square root of 130. So the square root of 130 is going to be in between 11 and 12, somewhere between 11 and 12. Okay? Okay, we want to refine our process a little bit more so we can get an even better estimate. We want to be able to estimate at least to the tenths place. So we're going to have to decide, do we want our estimate to be less than 0.5 or greater than 0.5? And one way we do that is we look at how close are we to the different perfect squares on either side of our problem. So for the square root of 106, we've already thought in our head that 106 is between 100 and 121, the two perfect squares, which means the square root of 106 is between the square root of 100 and the square root of 121. Square root of 106 is somewhere between 10 and 11. Okay, but we want to know which one is it closest to. So again, in your head, you can be thinking, alrighty, 106 minus 100, the difference between those two is 6. The difference between 121 and 106 is 15. So I must be closer to the square root of 100 than I am the square root of 121. So 106, square root of 106 is closer to 10 than it is to 11. Okay, see how we're narrowing this down. Okay, so go ahead and take a minute. Think about and write in what perfect squares are on either side of 250. Hopefully you came up with 225 and 256. So we're looking for a number between the square root of 225 and the square root of 256. This number is between 15 and 16. Okay, so then again we're thinking about which number is it closest to? Which of those perfect squares am I closest to? And so you find the difference. 250, the square root that we're trying to find, and we want to know how far 250 is away from 225. Okay, it's 25 units away. The difference is 25. And what's the difference between 256 and 250? Well, the difference there is only 6. So the square root of 250 is actually closer to 16 than 15 this time. All right, let's try these. Each square root is between two integers. Name the integers and determine which integer the square root is closer to. So the square root of 19 we know is between the square root of 16 and the square root of 25. You either have that memorized or you're using the chart. Okay, so the square root of 19 is somewhere between 4 and 5. And then you want to find out which one it's closer to, so you can do this in your head. You're going to say, okay, what's the difference between 19 and 16? What's the difference between 25 and 19? Okay, so you'll calculate the differences. You can do that in your head. And since our 19 is closest to the perfect square of 16, we would then conclude that the square root of 19 is closest to 4. All right, I'll do another one with you and then you're going to be on your own. All right, the square root of 33, that's between the square root of 25 and the square root of 36. So the square root of 33 is between 5 and 6. But which one is it closest to? Okay, in your head you're going to find the difference between 33 and 25, and then the difference between 36 and 33. Okay, and then because the difference is closest to the 6, we would say the square root of 33 is closer to 6 than it is to 5. Now you go ahead and finish the other two on your own. All right, now we're actually going to want to be precise with our square roots. So to be precise, we're going to use a calculator. So go ahead and use a calculator on these 4 problems. Calculate the square root to the nearest tenth. But I challenge you to estimate it in your head first and see how close you can get. All right, let's get to some story problems. The distance that a person can see from a certain height to the horizon can be determined by using the formula view equals the square root of the quantity 1.6 times height, where the height is in feet, pay attention to your units, and the result is in statute miles. Miles between cities, that's an interesting unit. Okay, so for question 19, how far to the horizon could you see if standing on top of Pikes Peak in Colorado, elevation 14,110 feet? Round the answer to the nearest tenth. So our view, the distance that we can see, is equal to the square root of 1.6 times the height, and our height in this case is 14,110 feet. So our view is equal to the square root of 22,576, and the square root of 22,576 rounded to the nearest tenth, is 150.3. And of course we would add a nice finishing sentence here. You could see 150.3, and what are our units? Something interesting called statute miles. Okay? All right, and you go ahead and try number 20 on your own. Okay, in your own words, try and explain how to estimate the square root of a non-perfect square using complete sentences and some good math vocabulary.